So you see how the compass on the left half of the screen is always pointing at the ball? That's what we're covering today. And I did not know the best way to record this video, so I kind of did it twice. If you are an experienced user and you understand Fusion, watch the first half. If you are newer to Fusion or DaVinci Resolve and you want a better understanding of how this works, jump to this timestamp here. Let's get into it. Okay guys, so I'm gonna move fairly quickly through this. So again, if you need help, tune into the second portion of the video, but I've got two things working here. I've got my compass with an arrow, and then I've got my little circle here that's gonna be our tracked object. Now, the only assumption that you need to make here in order for this to work for your own shape is that one, the center location for whatever object you'd like to rotate and move can all be summed at one center position. And what I mean by that is that if I go and I merge this down under, the merge is at the absolute center. So I'm at 0.5, 0.5. Okay, if you want to use other kinds of transformations, life's gonna be a little bit trickier. So we just need to make sure our center position is summed at one location. And we also need to split this into an XY path for both. So right click, modify with XY path. Let me uncheck the keyframes real quick and then do the same for the others. So my merge node here, right click, modify with Y path, uncheck. And what this is going to do is it's going to generate a new path XY coordinate. So for the second one, it's going to be XY path 2. And if I hover over the X and Y variable, the bottom left corner of DaVinci Resolve, you can see it has generated these XY path variables. Now, in essence, to make this work, all we need to do is a little trig for the X and Y location. So if you remember good old SOHCAHTOA, that's what we're going to be doing. So what I'm going to do is I'm going to go ahead and reposition our compass here. I'm going to toggle our preview over to the media out. So I'm going to go ahead and resize it. And then to change the center position, we need to make sure we're in our modifiers tab. I'm going to go, let's go 0.2, 0.2. We'll put it in the bottom left-hand corner. And important assumption, this is something I should have mentioned in the first couple seconds. Your arrow needs to be pointing to the right. Whatever your pointer object is, it needs to sit on the x-axis here, and it needs to point to the right. Otherwise, the trigonometry is not going to work correctly. Now, the last thing you need to do is you need to go up to the tools menu. You need to change the expression or the angle at which it's pointing at. So what I'm going to do is I'm going to go in the expression box, equals, and then I'm going to put this expression in the description. Now, there are two key assumptions I make with this expression. One is that the path variables are going to be named exactly the same. If you only have two merge nodes, this should be it. But XPath1 is going to be the X position of your compass. That is this variable here that we've split up in our merge node modifiers X. That's this variable here. And same thing with XPath2. The other important assumption to make is I entered the aspect ratio as a constant. So I'm working on a 1080p timeline, which is a 16:9 timeline. To get the right angle, you need to multiply by the inverse of that. So I'm multiplying by 9/16. This is an if-else function because we're using the arctan, and tan is only good through 90 degrees. So again, we had to do something a little funky to make this work correctly. But again, the important assumptions are that we're working with the same XY path variables and then the aspect ratio. Once you have this all copied and set up correctly, you just need to go to your merge node, tools, paste this in here, bang. Now, no matter where I move my merged ellipse over here, it is going to point exactly to that object. Now, if that was going a little bit too fast, go ahead and stick around for a better explanation. With all that being said, what I'm going to do is I'm going to delete our merge nodes because I'm going to walk you through how you would do this for yourself. Okay. So the two shapes that we're working with are this circle with a triangle sticking out it. I'm not going to walk through how you build this yourself. The look and shape of your pointer arrow is completely up to you. What I will say is that when you build this out, it is going to be very important that it is located in the center. If it is not located at the center position, then you'll need to do more math than what I'm going to show. So you see how my shape is located in the center. And when I go and I merge it back onto our main composition down here, now I swap over to 2, Now I can move it using the merges center and size position. You could also do this with the transform node. I have a feeling it's going to be a little bit easier to do with the merge node. So now what I'm going to do is I'm going to resize and remove this. Again, the look and shape of this doesn't matter. The other really important thing that you need to know is that for the starting position, your arrow needs to be on the center position and to the right. This isn't the only way to do this, right? But you're just gonna need to do a little bit more math on your end to adjust to your settings. So if you want to follow along with me, make sure your arrow to the right. And again, it doesn't matter what the shape is, the color, like whatever effects you apply to it. So now that I have it merged, what I'm going to go ahead and do is I'm going to resize it just a little bit. And then I'm going to move the center position down and to the left. So let's go 0.2, 0.2, some nice even numbers, okay? So that's object one. Object two that we got working with here is a masked out circle. So we've got a background node here with an ellipse. Again, whatever this object is, it doesn't matter. But what I would say is that I would try to limit the changes in X and Y position to one node. The reason being is that we're only going to use a single expression to calculate the change in position. So if you're going to use more than one node to change the position of this object, you're going to, again, need to do a little bit more math. And you can set that up using like a separate calculation node or however you want to do it. But I'm just saying for simplicity's sake, what we're going to do is we're going to use one node to move this, and it's going to be a merge node. So I'm going to merge it back on top here. What I will say does matter, and I'm probably going to be a little bit repetitive in this video, is that the center position for whatever your compass and your object are equated in one point. So you see how our center position is absolutely at this location. There's not another transformation in the position. Our position is summed at one center point. And it's the same with this circle. It's summed at one center point. You can get away with doing more, but your life's just going to be a little bit trickier. With that said, that is the setup for this. I'm going to go ahead and show the math behind it. If you do not care, skip forward a couple seconds. I give you permission. So what we have here are 2 points. We have our compass center position and our, let's do it in red. We have our object center position. Okay, each of these has an X and Y coordinate position. So our compass here has, well, we're going to say an X1 and a Y1 position. And our object has an X and Y coordinate as well. And those are equated to our center positions, right? This would be X, if we're on our compass, this would be X1 and Y1. So again, if you forgot your good old trigonometry here, what we are trying to do is calculate this angle here, okay? So in order to do that, we can use our coordinates here to calculate that. And the way that we're going to do that is by measuring this length here, and doing a little SOHCAHTOA. So to calculate the angle here, we need to do the inverse of tan, or the arctangent. And we might be losing folks through here. So just know that this is kind of the methodology behind it. And this is what we're going to put into expression form. All right. So this equation right here, where we take the inverse of tan and calculate this length and this length, that is what we're going to be doing. That is the magic sauce in the expression. So there's a couple tricks to make this work. And one is that we need to separate our Y and X position. So I'm going to do that for both our merge nodes. In DaVinci Resolve, by default, when you're working with like a center coordinate, the X and Y position are linked and you get displacement instead of coordinates. So what we need to do is, and this is if you skipped forward, this is the start of the methodology to make this happen. You need to right click on the center position, go modify with XY path. This splits your X and Y position into individual coordinates. By default, they're going to come keyframed, so go ahead and unkeyframe those. And again, I right clicked on the center position, modify with XY path. I'm going to do the exact same thing with the other merge node. Right click, modify with XY path, go to the modifiers tab, uncheck the keyframes, and like I said, right, We've got the coordinates now separated. Okay, so that's step one. The next step is we need to figure out what is DaVinci language for the inverse of tan or the arctangent of this mathematical expression. And whenever I am going to be inputting a expression that's a little bit more complicated, I'll normally just open up a notepad or even just like a notepad plus, make sure I'm typing things out correctly. But what we're going to do is we're going to input this expression into the angle of our merge node. But to enter our expression, you can either right click and hit expression on our angle property of our merge node over here. Okay, right? This is the one that's going to be rotating and changing, right? Or you can go into the entry field, hit equals, type that down here. And now we have a line where we can type in an expression. Okay, and so from here, we just need to enter in this equation in DaVinci terms. So there's a couple of variables that we need to know the names of, specifically how we enter in the arctan or the inverse tan of this, and then our y and x coordinates. So let's get the coordinates first. What I'm going to do is I'm going to go over to my modifiers tab. And if you're ever curious about what an expression's variable name is, if you hover over that property and you look in the bottom left-hand corner, it will tell you. So for me, this is going to be xy path1.x. Y is going to be xy path1.y. These are important to know. And I'm going to go ahead and jot those down on a notepad. So y path1 x and xy path y. I'm going to go over to my merge 2 node now, hover over it, and sure enough, it's going to be very similar, except we got xy path 2.x and xy path 2.y. This is extremely important to know. This might be different for you depending on your fusion composition, okay? So this might not be one-to-one. If you're going and copying and pasting the expression from the description, you're getting errors. This might be a reason why. You need to know what your x and y variables are. So now that we know that, fun fact, if you go into the DaVinci Resolve manual, which is can be found by going up top to the help menu, and going to DaVinci Resolve reference manual, it'll pull up a manual with like everything and anything that you could ever want to know inside DaVinci Resolve. It's an incredible tool. Patrick Sterling always makes a video just reminding people how sweet it is. And we have our math expressions right here. In order to call math expressions, you need to do the following. You need to add the math prefix to it. So for us, it's going to be math.atan. Now what we need to do is we just need to write this out in DaVinci language, which is Lua. So what I'm going to do is I'm just going to, can I make this a little bit smaller? I'm going to write it out on my notepad and then we'll copy and paste that in. So it's going to be math.atan. We'll do open close parentheses. Go back in the middle. Let's go ahead and do our numerator first. So that's going to be, let's do open close parentheses, xy path 2 y minus x y path 1 dot y. Do our denominator divided, open close parentheses. And what I'm going to do is I'm going to cheat a little. I'm just going to copy this, paste it in here, and we'll just change these to x. Okay, there's one more thing we have to add here because this answer will come out in radians and we want degrees. So to get that to work, we just need to multiply by 180 and divide by pi. And you can't just type in pi. We have to use that math expression, which would be math.pi. That's the expression, or that's the variable for pi. So this equation will work almost perfectly. And I will show you what I mean, but first, let me just go ahead and copy this line, go back into DaVinci Resolve, got my merge 1 node selected here, our angle expression box open. Let me go ahead and paste it in there and bang. We are now pointing at a 45-degree angle. And so if I were to go over to our merge 2 node over here, go to the modifiers and I slide this around, you can see it is going to point to our object. Now, if I zoom in over here and I move the center position of our merge really close, you'll notice it's kind of off. It's like ever so slightly off, and that's because the aspect ratio of our canvas is not 1-to-1. We're working on a 16 by 9 canvas. So if this is good enough for you, there's no need to stress or to fix it. But if you did want to fix it, what you would need to do is go back to that notepad, and then we need to multiply by the aspect ratio. And this is something, this is where things can start to get messy. What you can do is input variables here that will automatically calculate the resolution of your canvas. Or what you can do is multiply this by the inverse of your aspect ratio. And so that's what I'm going to do. If you wanted to set this up and calculate variables, maybe I can answer it in the comments or something like that. But what I'm going to do is I am going to multiply this by, I think I want to do 9 divided by 16. That should work. Copy that, go back over to the merge node, paste this in. Bang. And now we're pointing directly at the center. So now if I move my merge node over here, now it's going to follow it 1 to 1. And again, what I did there, that little 16 by 9, that is because my aspect ratio of my canvas is 16 by 9. If yours is not, if yours is vertical or you're working in 4 by 3, it's going to be different, but you want to multiply by the inverse of your aspect ratio. If you wanted to input variables for these, what I'm going to do actually as well is I will leave a link to this expression sheet. It's an online resource, and there are some expressions here that you can use to get like your timeline resolution or your input media resolution. Now, like I said, this is going to work up to a point. And what you'll notice will happen is that if I go to that merge node to move my ellipse and I start dragging it over to the left, once I get past 90 degrees, that sucker breaks. It does not work anymore. And that's because if you forgot a little bit about your trig over here, tan is the only function that breaks, right? It's got, I'm trying to remember the name of these like infinity axes are called. I haven't done math in a while, guys, forgive me. But what will happen is if we go past this 90-degree point, it's going to break. Now, the reason why this happens mathematically is because our denominator becomes negative. So what we need to do is make our expression even more convoluted. And the way that I'm going to do that, and I'm not going to retype it out, I'm going to leave it in the description. And the way that we're going to do that is by using an if-else expression. If you have never coded before, all this means is that, let me go ahead and pull up the expression right here. If our denominator is bigger than 0, we leave the expression as is. Otherwise, if it's less than 0, so if it's a negative value, we add 180 degrees to it. That's it. That's the only stipulation. The only thing that is kind of funky to know about this is how to format it. And it's a long expression, so I'm going to put it description, and let me go ahead and do our times 9 by 16 as well. Again, your aspect ratio is different. You can either enter in an expression or a variable for these, or you can just change the constants. Let me go ahead and grab this line and copy, go to the tools, paste it in here. If you pasted it in correctly, you should still see an angle value. If this jumps to 0, it means there's something wrong with your expression. Now, if I go over to my merge to node, go to the modifiers, slide this over, now it's going to track it perfectly. Wow, look at that sucker go. And so you can do some pretty fun things here. So let's say I bring our circle over here, add a keyframe, drag it over here. Let's smooth out our path a little bit. And I play this back. Gonna follow the circle, which is so cool, man. It's so cool. I don't know how fast the playback will be on more complicated compositions. It might be pretty slow because we're doing a little calculations in the Fusion comp. But either way, that is so dang sweet. Whew. Okay, that's a lot of me yapping. It's a lot of math that we just covered. What I'm going to do is I'm going to show how we would apply this to a tracked object. Okay, so here's what I'm going to do. I'm not going to remake our compass, but what I'm going to do is I'm going to select our compass nodes, hit Control-C, go to the edit page, go to our astronaut here, right click, open in Fusion. All right, so this is take 2 because I found some funky things. So now that we're in the media our astronaut here. Let's go ahead and paste in our nodes, and let's go ahead and connect them on top. And we're gonna have an error because it's trying to use the expression from our old composition. So for now, let's go ahead and delete that. Hit enter. Now, if we go over to the media out node, okay. All right, so somebody speak up if they know of a better way to do this, because this is the workaround I ended up finding I had to do. Let me go ahead and add my tracker node. It can be whatever kind of tracker you want. I'm just gonna use the IntelliTrack because I have Studio. It doesn't matter, you can use the normal point tracker. But again, in order for our expression to work for the angle, we need to be able to access the X and Y coordinate of our center position, or the tracked coordinate, separately. But if I right click here, you don't get the option to split them into an XY path. So what we need to do is you move your tracker point to, let's go maybe right here. That seems fine. And in order to enable those, what I found you have to do is you just need to track forward one frame. What that'll do, I don't know what it toggles on the back end, but it'll give the ability now to like keyframe this property. And so what I'm going to do is I'm going to uncheck the keyframes that it's set. So boom, go back a frame, boom. And now what I'm going to do is I'm going to right click on the center position, modify with XY path. And if I go over here now we have our XY coordinates split up. So I can go back to the tools menu and track our position. So let's go ahead and track it forward and backwards. Alrighty, and so what we would need to do, and we're gonna be lucky here because of the way our composition is set up, is what we need to do now is go back to our modifiers tab, and we would need to now exchange the variable in our equation, our x2 and y2 position. But because this is technically the second path in this composition, if I hover over our x variable and go down the bottom left, it's gonna be the exact same variable. It's xy path 2 dot x. So what we can do is I can go back to our equation here, copy it, and then go to the merge node, tools, angle, paste it in, bang. It should follow it. And yep, we can see the angle changing right here. Pretty slick, man, pretty slick. I'm not sure what applications this will be useful for. I'm sure in the MoGraph world, this could be some pretty powerful stuff. Yeah, I will do my best to answer any questions I can in the comments. If you do have questions, I would highly recommend joining the Discord in the description. That is always a better place for me to explain things. I can provide visuals and that sort of things. But yeah, pretty neat stuff. Hope you guys enjoyed. Catch you in the next one. Peace.